Welcome, everybody. We're going to be working on Unit 8 today, which talks about two very important data structures inside of Python called sets and dictionaries. We did get a little bit of a preview of what these are when we did the Kahoot the other day as a little bit of a preview. My hope is that you did read that chapter in the book, Chapter 8. And if you did not, my recommendation then would be to watch the lecture video where I basically, manually step through the chapter, describe the concepts, and in some cases demonstrate how the code works. But I do want to go back over here. We were just talking about this before the recording kicked on about this site called W3 Schools. If you're not familiar with this site, I usually introduce this to all my web students right when they get started. It's a website built by an organization called the World Wide Web Consortium, which is the standards issuing body for the internet. So they are the ones that set the rules for HTML, CSS, and JavaScript and how they operate in a browser. And you can see on the menu here, those are like the first three listed. So it talks about all the different aspects of the code, how to utilize the code, and has these little what we call try it windows where you can go in there and tinker with the code and see how it works. If you go past that and you look at all the different things they have on your menu, they are really expanding, and now they have a lot of the other key technologies. And by the way, we teach all three of these. We teach SQL, Python, Java, PHP, C, C++, C Sharp, Bootstrap, React, MySQL, jQuery. And if you're in our data science program or artificial intelligence program, you learn a lot about Excel, XML. Django is a framework. There's NumPy, Pandas. Those two are Python libraries, by the way, very advanced ones. And it goes on and on and on, right? So they have become, I'm going to say, one of the best reference sites on the internet where, if you're going to look something up and go, how do I, whatever in the language, this is the place you go to. So I'm going to click into the Python area here, and you'll see as we kind of like look at just the sidebar, and I'll zoom in just ever so slightly here so you can see the topics. And then as I kind of scroll down this list on the left, think about all the stuff that you have already learned, and we've gotten pretty far down this list. So we've talked about syntax and comments and variables and data types and numbers. Casting has kind of been happening automatically. It's the result of mathematical calculations, but we've been talking about Booleans, different operators, whether they're assignment operators or logical operators. We've just looked at lists and tuples, and now we're about to go into sets and dictionaries. And then they also talk about if else and while and for and functions and lambdas and yada, 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 right? And we will hit upon a few of more of these, but we do run out of time ultimately to cover every topic, in Python. But if you want to like further your studies, this is a great place to go to do that. And then you'll notice as you get to the advanced levels of Python, then you start getting into the AI stuff. And machine learning and how that all works, and how you can take Python and interface it with a database, whether it's MySQL or MongoDB, and then they have a complete reference library as well, and it goes on and on and on, right? So very cool site for Python people. I am going to, at least for just a moment here, click into the sets and dictionaries area, which I think I just scrolled past somewhere. There it is. So we can kind of reinforce those concepts we were talking about the other day before we begin to code. Now, if you remember kind of going through this process, this is what a list looks like in Python. So we basically denote it with the square brackets. And I think if I zoom in far enough, it gets rid of the ads. There we go. And so a list is basically a single variable construct that contains multiple values. The list items are ordered or indexed with numbers. So apple would be 0, banana 1, cherry 2. If we look at tuples, right? Very similar to a list, but the difference with a tuple and a list is that tuples are unchangeable, right? And so very commonly used if you import data, you're processing data, you don't want to alter it, but you want to make it process as fast as possible. Tuples are often the choice. The only difference in how you put them together is you use parentheses, right? And that's how we can tell it's a tuple. The other one that we're about to learn is sets, and sets are based upon, um, and I think we pointed out, it was called the Venn diagram, right? Where you have like the box and the two circles, and sometimes they overlap and sometimes they don't. And you can join those circles or intersect those circles and do all sorts of weird things. The syntax difference here is the fact that we use curly brackets to hold the stuff as opposed to parentheses or square brackets. So that's how we know it's a set. Um, yeah. So this is really kind of interesting. It says set items are unchangeable, but you can remove items and add new items. Now, to me, that says it is changeable, but I can't change the item when it's in there. So I can't take, like if I had an apple in my set, I can't turn that into an orange, right? I just have to remove it and then add an orange. And that's kind of the point. You also cannot index this. So you don't have a numeric value to indicate its position. So I can't say, well, I want Apple because it's in position 0. That doesn't work. So it is not indexed. And so therefore there is no order. It's just kind of like throwing stuff in a bag and then it's in there somewhere, right? You also, in principle, and I think we learned this from the Kahoot, that you can't duplicate values in a set, right? Like, um, all right, I threw a banana in the bag. All right, I already have a banana. I don't need another, right? So that's kind of weird. Um, but it's still a very useful thing because it becomes very flexible and it allows us to do a lot of things that are related to set theory and logic. All right, so let's now look at a dictionary really quick. So we're going to cover this one too. And a dictionary is another data structure. The difference with this is we use this construct basically that we call a key value pair, right? And you can see that's highlighted here, right? Key value pairs. So we still use one single variable name. The contents are not ordered numerically, right? However, they are ordered with the key. So all 3 of these things would be considered keys, and then all of these would be values, right? And if you kind of break this down, it really kind of mimics the structure of a 2-dimensional spreadsheet or table, right? Um, so in other words, like if you can imagine, like you had like an Excel spreadsheet, for example, and you had columns where you said brand, model, and year, and you listed, Ford Mustang 1964, and then you on the next row you might have like a Toyota Highlander 2006 or something like that, right? You just um, but each piece of data, right? This is really the data, um, is attributed to a key, and often the keys repeat and the values change. So notice there's a separator in between that says that this is the key and that's the value, and then when we have multiple key value pairs we just separate them with commas. So these are sort of like lists, except when you look something up you use the key to look it up, not a number. Right. So that's really pretty fascinating, actually. Now, why this is really important, especially the dictionary structure, is when you look at this other technology called JSON, and I don't know if they talk about that here or not. I kind of hope they do. Maybe not. All right. But JSON is what we call JavaScript object notation. And basically the way JavaScript object notation works is we have key value pairs, right? So like you notice how this is almost identical, right? The only difference is we have curly brackets kind of creating levels of it. And this is actually a pretty um, complicated one that we're looking at. But why this is important is this has become the number one data transmission mechanism over the internet or for sending information from, let's say, a database over to an application or a website or whatever, right? And so dictionaries kind of share that feature, that key value pair. In some languages, like most of the C languages, well, it depends on which one, real frankly, but in languages like Java or PHP, we will call this an associative array. So we associate a key with a value. All right, so that's enough of the lecture stuff. Let's go ahead and dig into doing the exercises. We have a number of them to do. So there's 5 exercises, so we may as well get started. I do want to point out the fact that there are a couple of data files that are provided here in advance. So if you are on your machine, you can go ahead and download these. Now, I just want to show you, like, if you go into Blackboard and click on these, and you know what, I'll do you guys the favor of throwing it into the chat so you don't have to do that. But if you click on it in the browser, this is kind of weird, right? It just loads up in the browser. It gets the text file, the browser can do it, so it just does it. So this is one of the files. And then we also have this one, which is a Python program. And so, and of course it tries to execute. So, all right. So let's not worry about that. But so basically you're given a starter program to work with for one of the exercises, and the other one is a raw data file. Why this is important for us, by the way, is that if you are going into the areas of artificial intelligence or data science, where Python is used very, very heavily, these once again are examples of like using information in external formats and then using Python to do the processing of those files. Very, very common, by the way. Now, what I'm going to do here is I have the files kind of pulled aside, and I'm going to first throw the raw data file into the chat. And I think what I did here is I threw everything into the chat, which was not good. I had everything highlighted, but here's the raw data text file. You will not need this immediately, but now you have it. And then that int.py file. Oh yeah, it's trying to run. I don't want to do that. I want the folder. Well, this is coming with a little extra baggage, and you'll see that it's got that. I'll show you my file window here. It's coming with a space and a parentheses and a 1 inside of it. In which case I must have it in this folder already. This is my downloads folder, but you would want to rename that and get rid of this part of it basically with the space. So, yeah. All right, so let's get to the exercise descriptions then. I'm gonna go ahead and open up that Word doc here. And let's see which ones we have to do. We got to do exercises 1 and 2 to start with. That's pretty easy to remember. And so the first directive is write a new version of the int name pi from chapter 5 that uses a dictionary instead of if statements. So now you're going to see like what the power of this is. Now I'm going to go ahead and open up that file, and I think I made the mistake here of just closing it, but I guess it's in the chat. And so if you open it up from the chat, make sure you hit the download button. I'm just going to throw this on my desktop right now. Just going to save it there. And then I'll use my file window here to go find it. It's called intName.py. And then what I'm going to do is I'm just going to drag and drop it. I already have Spider running down here, and I'm just going to drag and drop, hover over it in the toolbar, and pull it right into the IDE. And I don't know if you guys recall this one, and this is why I don't want you typing this in, right? Because there's a lot of code here. So it's easier just to take this and manipulate it and turn it into the thing we need. So we'll go through this process here. All right, so now I'm just arranging my screens here on the other side. But if you remember what this does, it basically takes a number and turns it into its English name. That's kind of, so like you type like, 1, 2, 3, 4 into the prompt, and then it'll go 1,234 in words, right? And the way that we did that here is we, aside from having the main function, we wrote a series of if statements. So we would read the number in, and then we, set up a variable that would hold the name that, it starts as an empty string, but we build the string, we concatenate to it to build up the name. And then we just start asking a series of if statements that checks to see how many digits we have. And then, based on mathematical calculations, a combination of floor division and modulus and a couple clever, greater than or equal to's or whatever. And we break it down to the point where we're running these external functions, which then also have if statements in them, looking for certain values and then returning strings based upon that. You can see how much like text there is here just to do this, right? A lot, right? There's a lot here. I mean, it pushes on like 85 lines of code to make it happen, but it does work. So for example, let's just run it, and I'll zoom in. Oops, zoom in over here. Right. So if I typed in 1, 2, 3, 4, it would tell me 134, and that's not even working correctly. So apparently, oh yeah, it says under 1,000. All right, so let's try that again. So 954. Now, of course, if you wanted to add, for example, thousands to it, then you would write another series of if statements, et cetera, to make it all happen. But it takes a lot of code ultimately to get it to work. What we're going to do is we're going to re-engineer this. So we're still going to have one little area of if statements, but we're going to tweak that area, but we're going to remove all of these, unnecessary modules, basically. Now, the way that I'm going to proceed with this is I could just tweak this file. But I think what I'm going to do is I'm going to actually start a new file and then copy over the stuff that I need as I need it. Okay, so let's do that. I already have an untitled one here. Spider does that automatically. If not, you could basically create a new file at this point. What I'm going to do is I'll come to this new file and then do a save as, and then I'm going to go up to my root for this semester, create a new folder. We'll call it Unit 8. And I'll go into it. This is exercise 8_1. Save that. And then since we're going to be working with this one too, I'm going to do a save as on this one and put it in the same folder so I have the starting point. It already has a name. I just have to put it in the right spot. So for me, that's my Google Drive here. Spring semester, Unit 8, and save. All right. Back over to the new file. And I'm going to blow away all the comments here at the top just to kind of conserve on space. And then I'm going to begin with kind of a primitive program header, which describes what we're doing, right? So this program turns an integer into its English name. Now, we are going to use a main method. And what I'm going to do here is I'm just going to define that first. So let's define a main method. I'm going to just put in a comment that is nonsense, placeholder. Just makes it easier basically to escape the construct. And then way at the bottom, I'm going to do a call to main that will make everything run. We're still waiting here to do a couple of things, but you know what? The first thing that we're going to do when the program launches is we're going to prompt the user to enter a number. So that part isn't going to change. So I'm still going to call this. And in fact, I'm looking at my sample code here. I'm going to call both of these lines. So grab both of those. So we're going to prompt for input, convert it to an integer, store it in value, and then we're going to output the results, which we'll call a different function that will do all the work. All right, so grab those two lines and copy them over. Now we're getting an error here because it's telling us that int name is undefined. So we do need to declare that function. So I'm going to type this one in. I know it actually exists in the other program, but just as easy. It's not that much to type. So we're going to say def int name number and a colon. And then we'll do some processing here. Once again, I'm putting in a placeholder just for the moment. This is expecting, I think, a return value, which is why it's, yeah, it's expecting an indented block. So I just want the error to go away. So I'm just going to throw a print statement in there just to make the error go away. All right. Now, before we start to code any of the stuff that happens inside here, what I'm going to do is we're going to build some dictionaries. So we start with dictionaries and we're going to do a key value pair setup here. And I'm going to put those actually above the main program body. So this is kind of an interesting thought here. So if I'm going to be manipulating a piece of data, you know, I could declare any variable structure like inside the main method, if you will, or function. But if I want all of the functions in the program to be able to access that data as they need, I'm going to put them outside that main function, and we call that a global, right? So it's global to the program. It's outside of any specific function, accessible to all of them. Okay. So instead of using all these like weird, I'm going to go back to this, right? These, you know, digit name, teen names, right? So the way we call numbers in the English language, unfortunately, you know, between 10 and 19 is kind of weird compared to most languages. And then we have the tens names, you know, 80s, 90s, you know, etc. So we're going to borrow that, you know, at least the naming convention of that. So up here, I'm going to build first a dictionary called digit name, right? So notice the capital N there. Set of curly brackets, right? That's how we define a dictionary. And then we're going to start putting in key value pairs. So instead of writing if statements to associate a value with a number, we're going to just basically put the number in here with a colon, and then its English equivalent in text right next to it. So we will look at, you know, the number zero becomes the key, the lookup, and then the value that is associated with it is zero as in the form of text. And then, you know, it doesn't take a genius to kind of figure out the rest of this, right? So the rest of this really becomes going through all 10 digits and typing them in like this. Now, I will mention as I'm typing this that and you saw this when we looked at, like, I think that JSON example, that often when you're building dictionaries or doing associative arrays, what some people choose to do with them is they'll kind of format them like this. I'm not always a huge fan of doing this, um, especially in this example. I mean, that is a little bit easier to read, you have to admit, right? And it's still part of the same structure because of the curly brackets. But what I will tell you is that this can actually cause some problems, right? And so if I was working in JavaScript, JavaScript is a language that doesn't care which line your code is on. However, Python does, right? So this is, where it becomes different in this language. And I'll show you what you have to do in order to push something to another line. I'm going to finish out this line here though. So I'm going to go, I'm on 2, so I'll do 3. And then we'll do 4, right? And I'm not quite running out of space, but if you think about it, there's 10 single digit numbers in the base 10 number system. I've already got 5 of them on the screen, 0 through 4, right? So if I wanted to move to the next line to continue this structure, yeah, I could just put in a comma and you would think you could do that. But here's what happens. You can't in Python. You have to use a continuation character, which is a backslash. That allows us to continue that structure on the next line. Right. So then I'm just going to kind of resume here and type in 5 and then keep going. And yeah, I'm going to copy paste the rest. Right, so there's the rest of it. So I'll give you guys a second to type that all in. So basically, we're setting up our dictionary here. We're putting in our continuation character so we can go to the next line without the code breaking. And yeah, I could include that and do the other longer format. I think that's really cumbersome, frankly. And if I was actually truly writing this, I wouldn't care. I would just let that line go off the side of the screen, but it doesn't make for a really good example, when you're looking at the video in the aftermath. So this is digit name, right? And since we're going to be replacing, digit name, teen name, and tens name, I'm going to create dictionaries that go with each one of those. And I think you guys already have kind of figured out the pattern here, right? And by the way, if you're clever, you could copy this, right? Remove that, and there's your key value pair, by the way. So just giving you ideas. We're going to do the next dictionary now. So we're going to set up 3 dictionaries: digit name, teen name, tens name. And so let's do teen name, curly brackets, and then we'll start the process once again. We'll say 10, spell it right though, comma after the double quotes, and then of course we'll do 11, etc. And yeah, I'm going to do a little bit of copy pasting here, folks. I've already typed this before and have it handy, so why retype it? And with this one, I'm going to 3 lines because the words are basically longer. And it looks like that. So that's the teen name. I know you guys are probably busily typing, but if you use the little tip I gave you, maybe not, you can clean it all up. But if you're copy pasting and cleaning it up, be really methodical about the cleanup on it. Because it's easy to make mistakes. Just make sure you have key, colon, the value, a comma, continuation marks at the end of the line, open and close curly brackets. Of course, if you're using a decent IDE, it will, warn you that you've messed up your syntax. And in an ideal world, that would be the case. I'm going to grab the rest of the code here for all of this. I'm not even going to bother to type it manually since I already have it. Align them nicely like so. Now, really what's going to happen here is instead of us writing if statements, totally doable, right? But every time you run an if statement, it goes through this process where it looks to see if something's true and false. And then if it is or is not, it executes a piece of code. The approach we're going to use now is more similar to like if you walk into the library and you walk up to the card catalog and say, hey, um, let's look up 10. Oh, this is how you spell 10. It's more like that. It now becomes a lookup, basically in a structured piece of information as opposed to asking a question. So why is this better? Or you can question and say, is it better? And I'm going to say it is better because a lookup happens faster than a processing statement, in computer memory and the impact on the CPU. So um, this is more processing efficient, and therefore you can write faster code as a result. All right. I'll leave that on the screen, and hopefully you guys are kind of catching up here and typing that in. But now we need to work on this function. If you look back at our old program, we had gone into this habit of like, kind of um, doing this. And I don't know if we've had a chance to really talk about that here in class much, but when you're creating Python functions, Python does kind of have this standard recommended syntax, like when you write a function, that you tell people what the function does, what parameters it accepts, right? Any limitations on that parameter, and what it's expected to return, right? So like a different programmer comes in and looks at your code and goes, oh, that's what it does, right? Oh, you're supposed to send that to it, and then it's going to return this for you. It's kind of like basically, becomes sort of like a library of information in a sense. And this is kind of considered a standard format, right? So like whether or not you do this, that's up to you. I'm just showing it to you. All right. So now in int name, we're going to start to do some processing. And some of that processing, once again, is the same as what we've already done. So we will still use these first two lines, right? So we're going to take the number and throw it into this thing called part. Um, and it says the part that still needs to be converted, and then name will be where we build up our string for output, right? And maybe it's good to say build string for output. So we'll keep concatenating strings to this, and then at the end we'll just return and then print one name as opposed to like stitching it together in the print statement. All right. And I'm not sure if this is really good description, the part that still needs to be converted. But I suppose it is, right? Because what'll happen is we still will do actually most of the logic that we see here. So the int name function, really, I guess we could have copied the whole darn thing. But we're going to change, we'll copy it, and then we'll change some of the syntax. So grab all of these if statements and the return statement from int py. So I'm copying that. Oops, let me get that. Copy all that, and then bring it back over to your main program body here, and then replace this goofy placeholder stuff. Here's the paste. And you know what? I don't think I brought those other two lines over, did I? No, I did not. So I could have done it all. I could have just copied the whole function, right? Yeah. Hindsight is 2020. Right, so copied the whole thing over. Now we got to tweak it though, because here when we were calling digit name, right, we were actually calling a function that did the work with if statements and then returned a value. Here, we're going to switch that syntax, and I want you to watch what's going to happen here. The mathematical logic is still the same. So we're still going to do floor division by 100, but we're just going to switch these to square brackets. And so now, instead of running a function, now what we're doing is we're going to look at the dictionary called digit name, and whatever this mathematical value resolves to will turn into a number that's a single digit number. So for example, if I typed in the number 500 and I do a floor division by 100, which means how many times is 100 going to 550 or something, it omits the remainder, which would be 50, and I end up with the number 5. So I'm going to go to the digit name dictionary, look up the number 5, and then return the string back to name. Right? Pretty clever, right? Yeah, really clever actually, and kind of cool. You know, very simple little alteration, and this is a whole lot better than if statements. Then we're still going to continue the same logic. So we'll take the number, we'll mod it by 100, but this time we'll look at the remainder, right? So that will take that whatever number is left over and store it here. And then in the next if statement, we'll continue the regular logic. So if, so now we're down to the tens basically. So if that, 2-digit number is greater than or equal to 20, then we're going to look over at the tens name dictionary. You can see it right up the top there to pull the value down. But here's where it we have to do a little alteration, right? So this is close. And yes, we will have to convert these to square brackets, right? And in that way, dictionaries do share a commonality with lists, right? So if we're looking stuff up inside of a list or a tuple, we use square brackets to find it. Same thing happens with the dictionary. We're sending numbers in, but it could also be a string, right? So you could if the keys were strings, you could throw a string in there or a variable that holds a string. All right. Here, this logic is not going to serve us because in the previous example, we had 20 somewhere, right? If it's, it's in there as a number, right? And so if the number is greater than 20, whatever, so the logic is different. So here we have to do a little bit of math to correct that. So we are still going to have parts in here, but we're going to do floor division by 10, right? So that's going to take that part left over, and it's going to give us the first digit of that. Because I want you to think about this. If I typed in 543, I don't want to worry about the 3. I just want to worry about the 4. So I'll do the floor division. So if there's a 40 coming in here and I do a floor division of 10, now I have 4, right? But I want to get the word 40 out of it. So then I have to multiply it by 10 again. So basically getting rid of the 3, turning it into 40, and then I can come up to the table and look up 40. Right. Now, I could, and I had a student in the past argue this with me, I could actually omit the multiplication here and then just put single digit numbers up here, but that doesn't make as much sense to my brain, right? Yeah, so that's what you do, right? When we're done with that, we will still mod it by 10, and that will leave us with the 3 or the single digit number that's left over. And then here, we'll just change the team name to square brackets. Oops. Like so. And then that will just look up directly. So if it happens to be less than 20, this is the point, greater than 10, but less than 20, it will look up the number directly, right? 10 through 19. And then when we get to the digit name, all we have to do is convert this to square brackets. And then that will take whatever single digit number is left, because that's what will be the case at this point, and it'll look it up here and convert it to its name. Every time it finds the value, we are adding it to name. Now, I'm noticing here as I did this, I did it as name plus space, and I did that on purpose, because otherwise I would do space. Like if I did, for example, plus equals and omitted this, right? So this would work too, right? I would have to still concatenate space on there because I don't want the words to be squeezed together. I'm going to leave it as it was, but that's the code. That's all of it. So notice we took, okay, granted, there's a bit of code here, but we took something that was, 80 lines of code, and we converted it to something that's about half, you know. And if I would have put these all on one line, even smaller, and if I would have omitted, all the verbose comments, even smaller, right? But much, much less code. So I'm going to leave this up on the screen here. If you guys are busy copying it, I'm going to do a Control S. Just give you guys just a moment or two here to kind of catch up. I'll just pause the recording for a second. All right, let's go ahead and try to run this and see if it still gives us the same kind of results. That run button, enter a positive integer under 1000, and I'll use 564. And you know what? Let's zoom in here just a little bit. Press enter, and I'm correctly getting 564. Try a few different numbers, so it's not a bad idea to get a couple of runs on this. 12. Let's try a single digit number. Let's try another 3-digit number. Let's try a number that's 20. It seems to be working just fine. So that, folks, is exercise 8.1. It's converting the old int name pi program to a new one that, instead of using a lot of if statements, is using a few dictionaries. And you can see why that's efficient, right? It's very, very efficient in a lot of different ways, not only screen space, but also processing as well. All right, I'm going to flip over now, and we will work on the next exercise, which is exercise 2. So this one says, write a program that counts how often each word occurs in a text file. This is kind of an interesting little challenge. I like this one. All right, let's start by creating a new file. So here we are, and then I'm going to do a save as. This is exercise 8.2. Once again, I'm going to blow away all the comments here at the top. I'm just going to that stuff. Doesn't do anything anyhow, but I am going to put in just a little program description here at the top. And then I'll go right to our first task here. So our first task is to read the file name from the user and open the file. Okay. Now, normally I would do a try and accept here. In the interest of time, I'm not going to, right? But that's what you really should do, right? And if you want, if you remember the code that we came up with in the last session, where we gave the user several opportunities to type it in right, and then and elegantly handled the errors, and that was exercise 7.5. And I think maybe for the sake of the video, um, pull that one back up. So that was exercise. Yeah, I think this is the one right here. So I'm just pulling this up so that way anybody looking at this, if they want that logic, right, you could um, at least you could get the attempts. I guess you would start with this, the while loop, um, and the try to open with the errors and that, right? And then your other program code could fit in the middle. You don't have to do that, right? I'm just kind of pointing it out for the sake of people watching the video, because really, if you're writing a real program, you want to do that stuff. Um, but you know what? We want to make it work first, so let's focus on the making it work first part. So I'm just going to make this really simple, and I'm going to create a prompt for the user, right? So enter the name of a text file, store it in a in file variable. We only need to be in read only mode because we're just like counting the number of words in the file. So, you know, we don't have to change it. So read only is fine. Next, we're going to go ahead and create a dictionary that's going to hold everything. And I'm just going to make a blank one. So I'm going to call it counts, right? And what I'm going to put in here ultimately is every time I'm going to read through the whole file, whatever file I throw at this is kind of interesting. I take any text file with words in it, read through it. It'll grab each word, line by line, word by word, and then throw it into this dictionary, and then also store um, how many times it appears. So I'm going to write code. It's going to take the word, store it, and then associated with that word that I just stored, how many times it appears. So so basically, for example, if I find the word the, I'll make that a key, you know, and maybe it's like pertinent to even type it in here. So I'll find the word the, make it a key, and then the value for it, the colon, will start at, well, the first time I put it in there, it'll be 1, right? So the count starts at 1. And then as I go through and process all the text in the file and I find it again, I'll just go in here, look it up, see if it's there. If it's there, I'll add a number or add 1 to it, right? And then it'll just process the whole file. Pretty cool, actually, conceptually. Um, Very useful little program, by the way. All right. Now we're going to do the the processing part here, right? So we have basically our inputs, we set up our data structure, ready to receive information. And now we're going to start to process this. We've done some of this before, so this is not new. We're going to do a for loop. And then for each line in the in file, the file that we just opened, we're going to set up a variable called words. And in that line that we're reading in, so it'll go one line at a time. That's how it does it. We'll run the split function, which looks for spaces in the line and then uses those as basically the delimiters for knowing when a word starts and ends, because that's how it works, right? So in other words, it'll read in a line of text, find a word. Okay, there's a space. It ignores that, finds a word, finds a word, finds a word, etc. And so really what words is a list of words, right, for this moment. So it does it one line at a time. Now, since we have all the words in a list, now we can traverse that list to start analyzing if we have the word and counting them, right? So we'll start with, for each word in the words that we just pulled out of there, we're going to do the following. First, we'll take the word that we have and we're going to run the strip function on it. And what strip does is it removes unnecessary stuff. And I did this incorrectly. So normally what strip normally does is it removes leading and trailing spaces, but I'm doing an R strip, which is I don't want to worry about periods and commas, for example. And if you had, and I apologize, those need to be in double quotes. Or if you had other characters, for example, like this thing that I'm looking at right here, this line, it has a pound sign and a dash in it and parentheses. I wouldn't want to count those, right? Because those aren't words. Those are, you know, hash mark, dash, and parentheses, right? They're not words, right? The files that I'm going to use here will have periods and commas, so I want to skip those, right? And any characters you wanted to skip, you would put in the strip command, and it would extract it from the word. Right. The other thing that we want to do is if I find the word the with a capital T and the word the with a lowercase t, aren't they the same word? Yeah, they are. So I don't want to have separate counts because they're different cases. So I am going to convert everything to lowercase. I'm going to call the lower function to do that. Strip out the punctuation and lower. If you're wondering what happened to the spaces, well, the split command took care of the spaces, right? It just pulled the words, forget the spaces. All right, so now that we've got that stuff sanitized, or cleaned up a little bit, now we'll run an if statement. We'll say if the word is in our dictionary, counts as our dictionary. So if the word's already in there, what are we going to do? We're going to take that word. Now look at the lookup on this. We're looking up the word, right? So this will be a string instead of a number like we did last time. And we will plus equals 1 to that. Now this is really kind of weird because, okay, so give you the conception here. If our key lookup is the, and our associated value is 1, what this is going to do is it finds the word, but when I do the plus equals 1, it adds it to the value associated with that word. It's not changing the word, right? So it's going to increment this by 1. Pretty neat, right? All right. If the word is not in the list, what are we going to do? Well, we got to get it in there, right? So we're going to take the word. This is going to add it to the structure, and we'll set its value to 1. So in other words, we're going to take it, put it in, and give it the starting value of 1. And that's all the processing right there, folks. Very, very simple, but at the same time, very powerful. So we'll do our due diligence here and close the file. So we'll do in file close at this point. And then we need to be able to take a look at it, right? So let's go ahead and display the counts, and this should be a comment, right? Display the counts of each. And now, and this is kind of interesting too. If you're interested, and I'm just going to type this in the form of comments here. If you just want to see what is in a dictionary, you could just do it on the next line here, issue this command, which would be print counts. Yeah, you can take a dictionary and just output it. Just take the structure, put it in a print command, and it'll print out on the screen, and like with curly brackets showing you the contents, right? So that's actually pretty useful, right? Um, just to see what is in it. But here's what I'm going to do. We had the user enter in file name. We captured it. I'm going to put in a blank print command here. I just want a blank line. And now we want to output the contents. And because we're outputting at least almost the text file only has one word in it, uh, we're going to be outputting all the words that were found and how many times that word appears. That sounds like a loop, right? So over and over again. So for every word in the counts dictionary, I'm just going to do this print command. I do have one that's pre-formatted, so I'll just paste it in here. You guys can copy that. And we're feeding in two things. One is the word, and then the lookup of the value. So this statement looks up the value that's associated with the word. Now I do have something in there right now. I need to get rid of that to run this, but this is all set to run. So I'm going to do a Control S, but then we come up to the situation once again where we need a file to process. And I'm going to go to my file folder here. And yeah, I have some, and this is my work from the previous semester. And you can see I have 3 Beatles songs here to process. And you know what? Just for the sake of simplicity, once again, I'll throw all of those in the chat. But if you don't have these, obviously you can just go to the internet and find them, right? So like I just sent you all 3. And the reason I'm doing it is like if you look at these, so like this is Blackbird, right? I think I've already removed the punctuation from that one. Hey Jude, right? That one's got commas. Oh, I'm also noticing it's got apostrophes. Okay, so that might mess us up a little bit. But you know what? You can code around that stuff, uh, right? And I showed you how. Then she loves you. Yeah, yeah, yeah. Right. So that's a good one because a lot of repeating words in that one. All right. So let's go ahead and process these. But like if anybody was watching the video in the aftermath, um, you have to make sure that these are in the same folder. And right now they're not. So I'm going to copy all 3 of those, and then I'm put them in my current folder that I'm working in, which is this one. So if they weren't in the same spot, then you'd have to like engineer the path correctly, and we don't want to do that. So all in the same folder. Let's get that out of the way. And I know my file names because my naming convention, at least on these text files, is all lowercase, no spaces, .txt. So let's hit the run button. And let's start with Hey Jude. Of course, if I misspell this will fail because I did not do a try except. And then, if you want to add that logic in, that's on you. Not needed to earn your points, though, for this assignment. But if you're really writing a piece of software, you would totally do it. So for Hey Jude. All right. Oh, that's really interesting. You see what it did, right? So like, hey, 28 times. Jude, 39. Don't. That's interesting. Okay, so like the apostrophe, okay, they don't see that as a like a broken apart word. That's kind of interesting, but good to know, right? And then you can see all the other words that are in here. It does get a little weird towards the end, and I don't know if you guys caught that as you were looking at the tail end of it. But because we're not omitting parentheses, it's like parentheses let, is is included. If I wanted to fix that, I would just throw a parenthesis in here, right? And if I'm going to do that one, then I would do this one too, right? Should we try that? Let's try it. All right, so let's run it again. And this time let's do it again. Didn't quite work, did it? Yeah, it didn't really quite work. So you might have to sanitize it a little bit. Yeah, that did not work at all. All right, so maybe you might have to go in there and manually remove that stuff, or maybe there's a different syntax for stripping those out. But I think that maybe it's R strip itself that's the problem here, because I think R strip syntax uh, might only handle standard punctuation, so there might be a different strip command for parentheses. All right, whatever. Pretty irrelevant. It is basically working though. Let's try it on the other files. So I'm going to run it again. This time I'm going to throw in Blackbird. Now that one I know is sanitized, so I don't have any punctuation in there at all. So this one should work pretty well, right? So Blackbird singing. Yeah, it's kind of interesting, right? So Blackbird singing in the dead of night, right? The whole first line is in there in order because all the words are unique, right? Um, and actually, take these broken wings and learn to fly. Right, so the words that really don't repeat for quite a while, and then but it does get a count. And if you wanted to verify the count, of course, you'd open the file and count, right, and see if it's working. Let's, for the sake of it, since we went to all the trouble, let's do she loves you. Well, she 20 times, you 36. I want to find the yeah. 29 times on yeah. Well, see, I would have thought the yeah is right. It was the number one word in there, but apparently not. A U is the number one word in there. All right, so that's exercise 8 to you guys. And here's what we're going to do. We're kind of reaching this point here, and I'm not sure if it's logical to do the next exercise or not. Let me take a look at what that exercise is. I'll pause the video here and see if we can kind of squeeze it out in the time that we have left. So I'm pausing the recording. All right, so the next exercise is kind of an interesting one, because it talks about this thing that comes from ancient mathematics, basically, where they call it the sieve of Eratosthenes. And basically what it is, it's a function for computing prime numbers. You know what? I'm going to change my mind on this. I think I'm going to plow through and just record it anyhow. But basically, what this is about is, um, you know, basically over a couple thousand years ago, um, without the use of computers and whatever, just using, basic mathematics, this guy named Eratosthenes figured out how to figure out the prime numbers, right? So a prime number is a number that is only divisible by itself and one, right? So you can't like subdivide it by anything else. If you take this phrase, and this is really pretty interesting, and I'm kind of like operating in hurry up mode here. Just Google that. There's a kind of neat little thing on Wikipedia, and they show here all the numbers first. You see the graphic that are divisible by 2, and they highlight in the chart. As you go through the chart, it will then do all the numbers that are divisible by 3, right? And anything that's highlighted in the color is not a prime number because it's divisible by something else, right? So first you eliminate everything that's divisible by 2. Then you go ahead and you eliminate everything that is divisible by 3 that hasn't already been crossed off the list, right? Um, and 4 has already been eliminated. So I think, I don't know if it does it, number by number. whatever, but it just goes through and this is all the numbers up through 120, by the way, right? So now you see fives. This is a pretty fascinating algorithm. Um, and it's pretty interesting that they even thought about this as a thing a couple thousand years ago, right? Like who cares? Like, but when you think about some of the advancements that ancient cultures had in terms of things they were able to build, or the astronomy they were able to figure out, or the sciences that they developed, a lot of the stuff they did back then still affects the modern world. Like they were really, really smart people back then. And they ran this algorithm here, and there's the list of all the prime numbers from basically 1 up to 120. All right, so what I'm going to do now is I'm just going to very quickly get over, and I'm going to do this in, I'm going to call it like hurry up fashion, and with a lot of copy pasting, and then you guys will have to watch the video in the aftermath. This is exercise 8.4. Zoom in. All right. So we're going to start with a couple of things. First, we're going to import a couple of math libraries, and if you guys are getting in a panic trying to copy it, I'm just going to pasting it into the chat for you. Right. So from the math library, we're going to import the square root function. This is one of the aspects of this. If you go back to that Wikipedia article, by the way, and scroll down, they show you the whole mathematical proof on it, how it works, and they even give you the algorithm in the form of pseudocode. But they do use square roots. And yeah, all right. So that's enough to put a lot of people into a panic for sure. We're also using this thing called floor, which allows us, when we're doing square root, to round down, basically. So we're going to prompt the user for a positive integer, and we'll use 120 because otherwise it'll take a long time to process. And then we will start with creating a set. So there's a command. So basically what primes will be is a set. And when we create a set, right, you notice I'm hovering over primes. There's a set function which allows us to build a set, and rather than doing it manually. So I could, for example, I'm just going to just type this in super fast. So I'm going to cut that, but I could create a set by simply, going like 1, comma 2, comma 3, or whatever, right? And that would be a set, right? However, I want it to build it over a range. So we're going to start with 2. 0 and 1 are omitted from the prime number thing, right? Because 1 divides into everything. 0 can't be divided into anything. And we're going to go from the number 2 all the way up to the number that the user entered. So for example, we're setting up starting point, start and end point, right? So we'll start at 2 and we'll go up to 120, right? But because the range command in Python never lets you hit the last number plus 1, right? So that's what we're doing. Then we're going to set up, okay, so for those of you not wanting to type, here we go. And then we're going to do this for loop. We're going to traverse it. So we're going to go from 2. But when we do the for loop, we don't have to go all the way up to that 120. We'll take the square root of the number we typed in and then do floor division on it. And we don't need to go any further than that. So for example, if I put in the number 25, right, and I did the square root of that, that's 5. We'd go 1 beyond it to 26, right? The floor thing gets rid of any, artifacts or remnants or remainders, whatever. So this is the outer loop. So that'll go from 2 to, if 25 is the example, up to 6, right? And then what we'll do is we'll run another range command here. We're going to go from 2 to the number cut in half uh, to figure out what we're discarding. Now, you can read up in the Wikipedia article all you want about the proofs on this. I really don't want to kind of get into it here, but that this logic works. And then what we do is we're going to use the discard command, which is going to take the I and the J, the two loops that we're running, the index values of those loops basically, multiplied together, right? And discard whatever value it comes up with, right? Because if you can multiply the two numbers together and reach a number, well, then it's not prime. And so we'll find that number in the set and discard it, get rid of it. Only thing left to do is do some output. Here's the output statement. Broke something in my code here. One too many parentheses, probably. That's exactly what it is. And then what's going to happen is we'll just have a message on the screen, and then we'll loop through the set that we have. But notice I'm running a command on the set. I'm sorting it. So I can read in the information from the set, because set information, remember, is not indexed. It doesn't have like a 0, 1, 2, 3, whatever, and it doesn't have a key value pair to order it. A set literally is like, just throw it in the bag. It doesn't matter, it'll get jumbled all around. Who knows where it'll end up in memory. So we have to read it in, sort it to see the result, to get a result like we saw on Wikipedia. And then for each one of those, we'll basically put in a space and then show the number. All right, let's run this so you can see that it works. Here's the run. Enter a positive integer. So I'm going to start with a small number. We'll do 25. Right, the prime, and it should say the prime numbers less than or equal to 25 are, and indeed those are all prime numbers. A lot more prime numbers lower in the range than when you get higher, you would think. Let's try that larger number that they were using. They used 120. And I don't know if you remember the output of it, but but there they are. We really want to have fun with this, and I want you to be really cautious about this too. You can start entering in larger numbers. So if I put in like 1,000, right, it will process 1,000 numbers. Notice how fast it did it, right? I mean, it was like, instantaneous almost. So these are all the prime numbers up to 1,000. Don't believe me? Try doing some math with them. All right, take it even further. So I did 1,000. What if I did like 100,000? Now it's thinking. So, but it still did it. Only took like 2 or 3 seconds. And then let's even take it up one step further. I'm going to go 1 million. So 1, 2, 3, 1, 2, 3. So that should take 10 times as long as that last one. What's fascinating about this, and I say this from an interest standpoint, there are people out there that run these huge computer programs that are infinitely trying to calculate all the prime numbers out into infinity. And every once in a while, they have a success and find a new prime number. It's very, very goofy stuff. But you see, it does take a long time to process, but it will process. And this is what's fascinating about Python, is it can handle that stuff. It might take a few moments, but it will handle it. I do see it's 9 o'clock. So those of you that are here in class, you already have the solution on the screen here. Grab it whatever way you can. This video will end here, but this will output a result. In fact, I'll pause the video and show the result in the afternoon. And as you can see, it finally finished. It took about a minute or so to get up to all the prime numbers up to 1 million, but it did work. All right. Take care, everybody. I'll see you in a couple of like 10 days or so. This video ends here.